So modularizing a program. When you define your module, you define the module header, the module body, and the module return statement. So if you're going to write a module that's going to add 2 numbers, in Python it would look like this. Like that. In pseudocode, just do this: Python parentheses x comma y. You remove that d, and then you have the same thing. Your set result equals x times y. Then you have your return. Just accept that you tab return in the real programming language, but not in the pseudocode. So this is the header up here, right? This is the first line, that's the header. Everything after that's the body. It can be 1 line, it could be 1,000 lines, and then the return. In a flowchart, you define the module in the same shape that you put the start. A terminator shape. Just like the start. And you can have modules that call modules and that call modules. So if we were going to write something like this, and I am going to actually use the word def even in pseudocode, just because I think it makes it so clear. Why did I say Python here? That's because I flaked. That should not be Python XY, that should be add XY, because that's what that function is doing. So I'm going up and I'm editing my notes here, if you're typing notes along. Add. Alright. So I'm going to write a module called Fred. All it does is output Fred and returns. And I'm going to write one called Barney that outputs Barney, calls Fred, and outputs Wilma for some reason. And then I'm going to write a start that all it does is call Barney. So what does it print? Well, these are definitions. The definitions are skipped, so to speak, until it finds the main line of the code, the main body of the code. In a Python program, the main body is the first unindented line of code. In pseudocode, the main body of the program is the one that starts with start. If you feel like putting a comment there that says #main, you could do that. Okay, so erase it down here. It says I'm going to call Barney. What does it do? It runs up here, prints out Barney. Then it invokes Fred, so it runs up here and it prints Fred. It returns back to here. It's done with that, so it prints Wilma, and it returns. So this would print Fred, excuse me, Barney, Wilma. What am I doing? It would print Barney, then what's next? After it's printed Barney, what's the next thing it does?
Ask for input and it have Fred.
Yeah, no input, but it calls up here and it does Fred.
Gotcha.
And then it returns from the Fred module, it's here, and so it prints Wilma. So when a main program wants to use the module, it calls the module's name. Here we want to run the Barney module, so we call the Barney module. The more techie term is invoke. So in a flowchart, the symbol you use to call a module is a rectangle with a bar across the top. Well, maybe it's a bar across the top. In our flowcharting program, it's the bars along the sides. Same thing. There's only one rectangle with bars, and so just use that one. And you place the name of the module that you're calling inside the rectangle. And then each module gets drawn separately with its own sentinel symbols. In my mind, that's the wrong term. It should be called terminal symbols. You know, the two ovals. The return goes in an oval, and the definition goes in an oval. Like that. Well, this doesn't show it. This shows modularizing the program. It's what we're going to turn into a module. So we have our start. We have some declarations. We have some input. We have some output. We have some more output. We have some more output. We have some more output. And we have some last output. So if we looked at the code, we have some declarations. We have an input statement. And then we output the address and the customer name and the total. So what's that going to look like when we break it into modules? They don't show us. Alrighty. So statements that are taken out of a main program and put into a module have been so-called encapsulated. Right? Just like a capsule of medicine, you put a layer around them. If you take stuff out of the main program, you put it in a module, that's called encapsulating it. So the main program becomes shorter and easier to understand. Important thing is that modules are reusable. You write some cool modules, you can put them in their own file and then import them just like we did with the import turtle. Or you copy and paste them. You know, either way, you get to reuse those modules. And so when statements contribute to the same job, we get greater functional cohesion. Why don't we Google up functional cohesion? Because I really doubt that they bother giving us a good definition of that. In the book, yeah, but we want to see it right now. A functionally cohesive module is one in which all the elements contribute to a single well-defined task. What does that mean? Say you're writing some code and it's supposed to, ask for some input, it's supposed to do some calculations, and then it's supposed to do the output, right? Same kind that we've been doing. Well, if you have a functionally cohesive module, you wouldn't mix parts of those together. You wouldn't mix the calculation with the output. You do those in two separate steps, two separate modules. You don't mix them together. You try to write a module to have a single task. Give it one task and do it well. Now, it may take several steps to do that task, sure. Maybe getting the input requires opening a file and reading the data in and closing the file and putting it together in a certain way, but that's still all just an input routine. What's that slide look like? Yeah. What is an example of cohesion? No. That's way too much. And then there's coupling. Coupling is kind of it's an important concept which I do not believe our textbook covers. Coupling is not a good thing. Cohesion is a good thing. We're not going to get a good definition on it. For Pete's sake. I should have found one before we started. Coupling. It's when two modules are linked together in a certain way that changes in one procedure can require changes to the other procedures. So the modules do not function independently. But sometimes you can't help that. Let's see if we can find a better example of that. Programming coupling. Coupling is a degree of interdependence between software modules, of how closely connected two routines or modules are. Coupling is usually contrasted with cohesion. So modules are independent if they can function completely without the presence of the other one. What does that mean? You know our example where we're going to be getting the input, to do our volume calculation or whatever, and then we have the volume one, the volume calculation. We don't want to write it so that the volume calculation does not work without the other function. Yeah, you have to have some input, but what if you just hard-coded the data values for testing? And here's what I mean by that. This would be a good thing of cohesion. Just what I'm talking about. I'm going to define a module called getInput, and it inputs the radius, and then it returns the radius. That's all it does. And then we're going to define another one, and I can tell it's not Python because I haven't put a colon there. I'm going to just call it P code for pseudocode. And because return is not indented, if I was going to change this into Python, I would have to put a colon there. I would have to rewrite the input statement. The input statement would involve a print, an input, and then a float. Float is equal to whatever in order to convert it to a real number. Alrighty, and then we're going to do calc volume of the circle, which is where we pass in a radius. So we have a radius parameter, which is just a variable defined within the parentheses. And then we calculate the volume as being 4/3 times pi times radius cubed. I believe that to be correct, unlike my pyramid calculations. And then we return the volume. And then down in main, I'm just going to put a little comment down here that this is our main code. We could get the input, set R equal to get input. We're going to get the input for the radius, and then we're going to set V, the volume, equal to calc volume, passing in the radius, and then we're going to output V. Now these are pretty good modules because this one is separate than this one. We can test them separately. We could call getInput, print out the radius, and go, yeah, the input module is working great. Or we could just pass in 100 there and then print out V and find out that it did calculate them. Now what would happen if we did something silly like declare what's known as a global variable? This is going to be a global variable, and this is not probably how you define global variables in pseudocode. Don't necessarily even type this because I'm probably going to delete it. And so what if this didn't return the radius? What if all it did is input the radius and store it in that global variable? Now what a global variable is it's one that exists for all the modules in the file. And then so down here we had this. And then the same way, calc volume depended upon that global variable. So now radius is not being passed in, right? It's not being returned. So we don't do that. We don't get one back from it, and then we don't pass it in. All right, so we've rewritten our module. Uses a global variable radius. What getInput does is it inputs into that global variable. It doesn't return anything. What calc volume does is it calculates the volume based on that radius without passing it in. So we call input and we call calc volume, and then we can. This would actually work in a programming language that supports global variables, which Python is one. But really bad programming. Why is that? You have to call get input before you could call calc volume. You couldn't test calc volume independently without radically revising your code. I hope that makes sense. These functions are coupled. They have to operate as a pair, which means that you could easily break the code by making changes to this one and not making changes to this one. This one has to do some setup, it has to do some input radius, it has to return the radius, and if we changed it, if we thought, I do want to get input to return something, and we changed it in a different variable, or we stored it as a string rather than, if we make some change there, then this one's going to crash because they're tightly coupled. You have two boxcars on a train. One of them crashes, so is the other one. One's bad, so is the other one. So coupling is making it so that the two functions are not independent. They are interdependent. Not meaning that you can't call them in a row. We still had it so that we could call our other functions in a row. That's fine. That's what functions are written for, to be called. But we ought to be able to call them separately. We ought to be able to call get input without calling calc volume. We ought to be able to call calc volume without calling get input if we passed in our own test data. All right, I'm going to undo all those changes involving a global variable radius. So I deleted the global variable. I'm making this return a value again. I'm making it pass radius in as a parameter. And then here I needed to get the input, and then I needed to pass it to calc volume. I hope you see the way this works. I'm going to tab all this all the way down and just focus on that. What's happening here? This is kind of what we've been seeing, right? Except instead of saying input R, now we're saying that R is equal to get input. This is our own module. We have written this module. This is our own function. And we get the radius so that we can pass it into this function, this module. So at this point, R is the argument to the calc volume module. And in this case, R is what is returned from get input module. So we get a return value, and then we use that to perform the next calculation. Now you use the word parameter at a certain point. Why are you calling it an argument now? Because the parameter is the name of the variable that receives the argument. The argument could be anything. It could be another variable, it could be a number, it could be something that's calculated on the fly. But this is the variable that receives it. If I pass in a 3 there, that value is the argument, but this is the variable that accepts that value. That's why I called this R rather than radius. If I made this radius like this, and then I made this radius like this, it looks good, it is good, it would work, but it implies to you, the student, and to anybody else looking at the code, without understanding arguments versus parameters, that this is this. It's not. This receives this. You know how when you go to the bank, you actually pass in money through the, through the window? You're passing in the actual money. That's not what's happening. We're not actually passing in the variable. This is not the same. It's not the money. Instead, we're photocopying the money. We're giving it to these people to do something with, to perform some calculation. But we still have our, our original money. And if they do something with the photocopy, if they toss it in the shredder, no problem. We still have our original money. So changes to this parameter do not affect changes to the argument. Now, honestly, I'm going to mix those terms up. I'll probably call them both parameters at a certain point. And other programmers will understand what you mean. If you say, I'm going to pass this parameter in. Well, it is a parameter at this point. But it's not strictly the same. Kind of like if you call the photocopy of a deed, you call it the deed. Right. It's not the deed, it's a photocopy of the deed. All right, I'm going to change this back because I liked those two things being separate. So this is our code as it stands now. Pseudocode for calculating volume of a sphere with modules. I'm going to write one more module called output volume. So rather than have start right here do the output itself, I'm going to write another module called output volume. So define output volume, and it's going to take the volume. Volume is its parameter, and all it needs to do is output. We have calculated the volume, and then output, and it is followed by the volume name. Again, this is pseudocode. It looks different than Python, and I'm really sorry that they're different. And I'm probably not going to ask you to write much more pseudocode, really, at this point. But it's a useful thing, because if I tell you to write Python, then you're supposed to compile it and fix all the syntax errors and stuff like that, and that's not true of pseudocode. So writing pseudocode is easier, actually. So maybe I take back the thing that says I'm not going to ask you to write pseudocode anymore. But I will offer you the option of writing your pseudocode as Python. And if I give you an assignment that says write pseudocode and then turn it into Python, I'll probably just let you know you do both. But pseudocode is faster. You could write in pseudocode half the time or less than Python. So if I ask you to write pseudocode on an exam, do that rather than write Python, take the time to debug it, right? You spend 45 minutes on your exam doing that. You've wasted a lot of time when you could have done it in 5 minutes with pseudocode. Hope that's kind of clear. Alrighty, what I want to do next is call my output volume module. Output volume, and I'm going to pass V in as my argument. V is the argument to output volume. Now we're going to flowchart it. So when we flowchart it, we're going to have 4 columns. We're going to have our main code. We're going to have a get input module. We're going to have a calc volume module. And we're going to have an output module. Now when I do my output module, I'm going to be annoyed that I put that much text there. But so be it. Why break these things apart? Because getting input doesn't necessarily mean getting it from the user. It might mean opening a file. It might mean querying a database. It might be establishing a connection to the internet and getting the input that way. And since these are not coupled, I could write this any way I want, and it's not going to affect the way that works. So that's a good thing. I could change this code to get input in other ways. Maybe it's actually hooked up to a sensor that goes and has a micrometer that measures the dang sphere, to calculate the radius. Whatever this input function is doesn't change the way calc volume works and output volume works. And then say we want to change output volume to do something cooler than just use print statements. Maybe we want it to pop up in a cute little dialogue. We could do that. We could make it pop up in a cute little dialogue, and that doesn't change this. Now, if we're going to pop up a cute little dialogue, we probably ought to have a window that lets them type it in as well, rather than make them do it in the console. But still, the idea is we can change these things. Say that we want to read this from a file, but we want to print it to the user. Great. What if we want to read this from a database and output to a file? Great. We have encapsulated out code into modules so that we can modify them separately. What if I write this, but I tell Josiah to go and write this? Totally works. We can have 2 people working on the same code, or multiple people, each one of them writing their own module, and then later on we hook them up like that. Then our program works. And that's the way professional programmers tend to do things, is they divvy up code into a large project into smaller projects, and each person is responsible for their own smaller project, and then you stitch them all together. Alright, I may have talked about that enough. I want to pop open good old Lucidchart, lucidchart.com, or if you want to use Visio, you can come down to type in Visio. The reason I don't use Visio is it's part of Office. You may not have Office installed. You may be running on a computer that doesn't support Office. So anyway, sign in with Google. I always go up and hit this login button, or at least I hover my mouse there, but we have Google accounts as our email. So I'm going to click Google there. Now apparently it's already ready for me, probably because I've used this recently. But if you have to log in, you know how to log in. Okay, if I scroll up and down, I'll probably find an example of some modularized code that I've written in the past. I want to see if I have one. Oh, of course I don't. Alrighty, well we're going to write our own. Meh, I'm disappointed. I really thought I had one ready. And by the way, at a certain point, I'm going to give you this chart here, gussied up a little bit, and it's going to be the Flowchart Cookbook. And these are going to be labeled. This is an if statement. This is an if-else. How do I know it's an if-else? Well, that looks odd. I'm not sure why that's there. Because this has two branches. This has two chunks of code being done. This just has one chunk of code being done. That makes it an if. That makes this as an if-else. Else implies that two separate blocks of code are being executed. If you don't see two separate blocks of code, and I don't mean multiple blocks of code just stacked up, you know. This is still all just one block of code because it's one branch. This is two blocks, no matter how many rectangles are stacked up. Two blocks means if-else. One block just means if. Now if you come over here and you see one block of code off a triangle, off a diamond, that's not an if. That's a loop. Why is it a loop? Because there's a line going back to the while statement. Now the textbook draws its loops going like this. It draws a line going back to the top rather than the bottom. I prefer going to the bottom because it eliminates the possibility of drawing an invalid flowchart. An invalid flowchart would be one that has a process block between this point and this one. If I took that process block that I copied at a certain point and put it here, this is an invalid flowchart that you could not program in a high-level language. Why? Because this is supposed to be the body. And here it's executing the body, but all of a sudden it's running back up here and it's executing this code. You can't write a while loop that runs like that. In assembler you could. In any language that has a go-to statement. Okay, I'm diverting. We're going to go back and we're going to do a file new. Blank diagram. And since I have my modules defined here, and my module definition is before my main code, I'm probably going to flowchart it the same way. I'm just going to copy this program and paste it into a block over here so I don't have to keep toggling between the two programs. Highlight it all, come to the alignment button. You don't have to do that. Kind of nice. Okay, so there's my code. That way I can just scroll to it and get to it easy. Alright, so we have three modules. We have get input. I don't have to use the word get. The book doesn't show it. Does get input take any parameters? If we zoomed in, is there anything between the parentheses? No, there's not. So I'm not going to put anything in the parentheses here. See there, I accidentally just called take any parameters. That's really not exactly the correct usage. I should have said, does it have any parameters? Parameters take arguments. But as long as you get the idea that you define your parameters in the function module header, but when you're calling the function, you call them arguments, then you've got it correct. Alright, so we have one function definition here. And notice it looks like a start. Yeah, well, it's in the same shape. It's in the terminator shape. The book just called it something different. The PowerPoint just called it something. It called it a sentinel shape. Bah hubbub. We've already said that a sentinel value is something completely different. That a sentinel value is a piece of invalid data that causes the program to quit, or the loop to quit. Enter your test score, or Q to quit. Right? You have to type in a number, but if you type in Q, it's not a number. It's not going to be added to your test scores. All right, so we've got get input. What's get input supposed to do? Well, if we were going to flesh it out, we'd have a print statement, we'd have the input statement, and then we'd have the conversion to float. We would take several statements. Let's do a little bit of that. Let's make our flowchart better than the pseudocode this time. Do you have to? No. So I'm going to do a print, or output. Output inner radius of sphere. And I'm probably going to use control enter to break up my text like that to make it prettier. Do you have to do that? Nah. Well, now it's already starting to look really ugly. Okay, I'm happy with that. I don't care if your text overflows. You're not going to get counted off because your text goes outside the boundary, but if it's easier for me to fix, I'm going to. Okay, so we output, and then we have the input statement, just like x is equal to input, parentheses in parentheses. What shape does an input statement go in? Yeah, what are you going to call it is always the question, but it's a data block, and I always just call them a tilted rectangle. Some people call them quadrilaterals, but honestly, a rectangle is also a quadrilateral, so is a diamond. Anyway, so that's why I just call it a tilted rectangle. But data block is the correct fancy term for it. So I knew you knew the answer, you just didn't know the term for it, and the term for it is kind of nebulous since there's more than one term for it. I like tilted rectangle. Call it a data block for absolute accuracy. Okay, so input radius. If your lines don't hook up, aren't perfectly up and down, great, who cares? You can spend some time fixing it later. If you want to fix it, hold the control key down and spin the mouse wheel up. Well, that didn't work. I don't know what it did. Hold the mouse key down. Hold the control key down, zoom in. It gets real close, and then it's easy to adjust the arrows, and you can zoom back out. So if you see me quickly zooming in and out, that's what I'm doing, holding the control key down and spinning the wheel. All right. And then what did we always do in our real code, in our Python code? After we got an input, we converted it to a float. Now that's math. That's not input or output, so I'm not going to put it in a tilted. I'm going to put it in a process block, in a regular rectangle. I'm not going to describe the conversion. I'm just going to say convert radius to float. Now try to talk enough to make following me easy, but if I start getting ahead, slow me down. Better to do that than to wait until the end and then say, could you scroll back up to this, and could you scroll back up to this, and stuff like that. And if we get to that point, I'll probably just print the flowchart out. And then lastly, what's at the bottom of every module? Whether indented or not. Stop is a good one, but the word I was specifically looking for was our return. So when it's our main code, it is stop, and they both go in the same shape. So I totally know why you said that. I'd give you half credit for that answer if I asked it on an exam. All right, so it goes in a terminator, and what do? We return the radius that we just calculated. Now, why did I flesh this out more than just over here? And would you have to flesh it out if I asked you to draw a flowchart on an exam? No. But I'm going to ask you to write this as a Python program. I'm going to give y'all, 10-15 minutes to try to create a Python program out of this using either the pseudocode or the flowchart. So I'm making the flowchart nice and detailed to make that easier. Okay, so that's that module. But we have two more modules. What's one of the other modules we have? If you can remember. If not, I can toggle over to the notes.
The other module was the volume, or no?
Yeah, calculating the volume. Exactly. Calc volume. This one does have a parameter. So when I come over here, I need an oval. It's going to have DEF, just because I like seeing that, even though the book doesn't do it. Calc volume. I don't care which way you do it. And then it had radius as its parameter. All a parameter is a variable that accepts a value. So that is a variable. We get to use it the same way we get to use all of our other variables in calculations and output statements and stuff like that. Alrighty, now this one's short and sweet because calculating the volume is just one step. So what am I going to... And I didn't write this one strictly enough. What do I mean by that? The book would have done some declarations here before it used R and V. Python does not require you to declare your variables before you do them, so I always forget to do it. Book perfect would be me to add a declaration block where I declare R and I declare V. Didn't do it, that's okay. Don't care if you do it on an exam. You can do as I say, or you can do as the book says. I try to keep them pretty close. Okay, so here we go. All this needs to do is a math calculation. 4/3 pi r cubed. So there we go. Set volume equals to 4/3 times pi times the radius cubed. Star 3, or you can express it however you think cubed ought to be expressed, but that's the Python way. So if you don't have an exponent function, you just multiply radius times radius times radius, right? The same thing. Other languages give you ways to do exponents that are completely different. You have to call a POW function a POW function, which means power of, if you're writing C programming. And it's called something else in Java, but they all have the same idea. Alright, and then, see, if I was coming over here and I was figuring out, let me add some spaces to my code over here so it's clear to read. Oh yeah, I forgot. When you add spaces, you have to hit the control key. Alrighty, so there was just one line of code in our calc volume. But we have one more module to write, output volume. So oops, what did I forget? And what would I count you off for on your flowchart?
The data, right?
Well, we've calculated the data, so what are we going to do with it?
Output it?
Yeah, we got to return it. We have a return statement here, and so we have to have an oval down here to return it. Otherwise, why did we calculate it? Return volume. And even if you don't get the answer to something 100% right, I would far rather people go ahead and offer answers rather than just have the class sit there deafeningly quiet. Okay, I'm going to kind of push that over. You don't have to do that. You don't have to, get everything to fit on one page. But I try to fit everything on the screen, or at least as much as I can, because it helps y'all in drawing it. But you don't have to do the same when you're drawing it. Plus, your monitors have more resolution available to them, since I run in 1024 by 768. All right, one more module, output volume. We know what goes at the top. Define output volume, and does it accept a parameter? It sure does. So volume is its parameter. Now, why didn't I just put this inside calc volume? because the way its output might be completely different, and I want this to be maintained separately. I want somebody to be able to write this independently of the calculation. It might pop it up in a window rather than print it in, the black screen. Okay. Draw an arrow down here. I have 2 output statements in my thing, so I'm going to wind up drawing 2 rectangles. Excuse me, 2 quadrilaterals, 2 tilted rectangles. Output, we have calculated the volume I told y'all that hint, and now I'm forgetting it. If you hold the Alt key while resizing, it keeps it in the same place rather than shifting it to the left or to the right, which is kind of useful. Still didn't have it perfect. Okay, there we go. I'm happy with that. Alright, and then I had one more output statement. We have calculated volume, and it is comma volume. And now we do have a return here, but it's not returning any values. That's why there's no variable after the return, unlike the other one. So it's just going to be returned without a variable. Still the same shape. The Terminator. Alrighty. Return. So those are our 3 modules. Now we're going to write a main that begins with a start and ends with a stop that calls those 3 modules. But I'm going to kind of run out of room, or at least I'm not going to be able to get everything on one page, or at least one screen for you to see. So I kind of want to hold off until I'm pretty sure that everybody has drawn these. Now we have to invoke these modules. That is done in this shape. Predefined process. Rectangle with bars. In Visio, the bars go horizontally. The book says that they go horizontally or vertically. I don't remember which way the book says. Same idea. Doesn't matter. Find that out real fast. So a flowchart, it's a rectangle with a bar across the top. Not in Lucidchart. On Lucidchart, it's got vertical bars. And in Visio, it's got a bar on the top and the bottom. I guess we can't be consistent. That would make things too easy. Just remember rectangle with bars. Okay. So here's what my program looks like, the main code. It calls get input. It calls calc volume. It calls output volume. Calc volume and then output volume. Yeah. Alright, that's how it's supposed to look. So, kind of run out of room. Do I want to draw it down at the bottom or to the side? I still feel like drawing it to the side, so I'm just going to grab that and push it over. Now our main code does also begin with a terminator, but it begins with the start. Start. That's how I recognize that it's a main code. And what does it do? It calls get input and stores its result in a variable called R. I remember that without scrolling it over, but I could demonstrate that to you. I could highlight that line of code. When you call a function, when you call a module, use the rectangle with the bar. So set R equal to get input, parentheses in parentheses. Now we're going to call calc volume. Does calc volume need an argument? Does it have a parameter?
Yes.
Yes, it does. So we have to pass in an argument, which is going to be R. So I'm going to draw another rectangle with a bar. Calc volume parentheses R. Trying to resize it, holding the, doing the magic trick of keeping it in place, and I'm doing it with the control key. That does not work. It's the alt key. All right, and then we call one more module, output volume. It does have a parameter, so we are going to be passing in an argument. So since it's a module call, we're going to put it in another rectangle with bars. So output volume. Now I made a mistake. If you typed in the code, or I'll bring the code back in just a second. I want to see if you spot my error. Compare what I've done here. I'll scroll over. And I didn't make this mistake on purpose. But I'm only human. Alrighty, so if I bring this code over here, here's our start and our stop. Do you spot a difference between what I've done and these three module calls? One of these module blocks has an error in it. Is it the first line? I'll just tell you it's not the first line.
You haven't set V.
Exactly, I didn't set V. And if I don't set V here, I'm not going to be able to use it here. You always have to set or declare your variables before you can use them. So, let's do that. Let's go add set V to that. Whoops. Set V equals calc volume. And then we're just at the stop, so that's one more circle, one more oval.
Click and drag.
The way I'm clicking and dragging is I click on the shape first, let up, and then I drag, holding the mouse button down. Does that make sense? Click, release.
You did all three of them.
Oh, if I'm going to do all three of them, I
Highlight,
click, highlight three of them. You can also highlight individually by clicking on one and then holding the shift button. Sometimes that works, but sometimes it leaves the arrows behind. But it's a cool way of highlighting. But I'll just draw a rectangle around it. All right, and then one final stop. If I can get it down there. All right, so things to notice. Main code begins with start, ends with stop. Modules begin with a module header, a definition, and end in a return, whether or not they actually return a value or not. Strictly speaking, Python and a lot of other languages don't require a return if it's not returning a value. This one's not returning a value, so you could leave that off if you were writing Python. But pseudocode does require the return. Flowcharts does require the return. It doesn't break the code if you have a return without a volume. So I'm going to try to always do it. That's the book way. Alrighty. I think I ought to ask y'all to draw a flowchart based on some code that I give you. But I'm going to make it pretty short so that we don't spend 30 minutes on it. And volumes are so easy that's why I keep using them as an example. Not that they're the most important thing in the world, but they're just nice little demonstrations. right, so the area of a circle is pi times radius squared, return area. So what this function does, calculate the area of a circle. Now we're going to calculate the area of a cylinder. Except I'm not going to pass in radius, I'm going to pass in area. And I need to Google this to make sure I get it right, unlike the pyramid debacle. Alrighty.
That's too much.
It is a lot of typing, but we'll run with it. This part is the area of a circle, so it's just going to be 2 times the area. And then we have some more rigmarole here. We'll figure it out. Let me copy that and paste it, make sure I get it right. Okay. So, I need a new variable probably, but I'm just, yeah. This one should not be called cal circle. We already have a cal circle. It should be cal cylinder, which I'm going to abbreviate to CYL. So we want to calculate the area. I'm going to call that cyl area for cylinder area. Maybe I'll put an underscore in it. I could have called it area underscore cylinder. Is equal to that. Let me fix it to exactly what I want.
Will Python be able to recognize that pi symbol or no?
It will not. There's a couple of problems with this formula. And if I give you a formula that looks like this, and I would tell you you have to fix it. The big problem, besides the pi symbol is one of them. It'd be interesting to see if we could define pi as a variable in our program like that. But you wouldn't want to, because how would you type it besides copying and pasting?
Yeah.
The problem is squishing all these together. Does that work? No, you have to put asterisks between them all.
So if I were to put that into Python, I couldn't do 2 times pi times r. I would have to define pi to begin with.
Right, and I'm going to go ahead and do that here. I'm changing it to that to make sure that it's real clear.
Is there an import for that, like there was for turtle?
There is. I don't remember what it is. We could figure that out. That'd be the best way to do it. Okay. Now that I'm looking at it, this is requiring a lot more stuff. Than what I have here. And what do I mean by that? How many variables do you have? Well, we've got pi, which you've been talking about, but there's several other variables here besides area.
Radius, height.
Yeah, we don't have radius and height, so I better pass those in as well. R and H. Otherwise, they're undefined variables. And then return cyl underscore area, which I'm going to untab since this is pseudocode. I wouldn't untab it for Python. Now that is a big hairy equation. I wish I could shorten it. And I think I botched something in it. Let me go and eyeball. I think something was supposed to be squared or something. Let me go look. No, that's okay to leave that one out. 2 pi RH plus 2 pi. Okay, so I tried to eliminate having to repeat 2 by putting it out here. If I wanted to shorten it, I would calculate this first. I can't think of a good variable name for it, so I'm just going to call it set A1 equal to pi times R times H. This is an example of simplifying expressions. There. but it's requiring more expressions. But it's using this one, A1, as a temporary variable, just so that we can plug it in here to shorten this one and not make it so complex that it would take a block size, you know, of a skyscraper in your flow chart. All right, that's good. Now I'm going to define a main method. Excuse me, main code. So it begins with start. We're going to set R for radius equal to 100, just for testing purposes because I'm too lazy to write an input function. Okay. Then I'm going to call cal underscore circle. And I could have actually called that from in here, right? Rather than passing it in to here. That would make, well, never mind. Alrighty, so set R, nope. Set A for area equal to cal circle, cal underscore circle, passing in the radius. And now we're going to calculate the area of the cylinder, so I'm going to call it AC. Unfortunately, cylinder and circle, you know, have the same initial letters. But we could always add comments to make that clear. Cal underscore cylinder, radius, excuse me, area, radius, height. And again, I've made a mistake here. And an output area of cylinder is, comma, AC. Same mistake I made in the middle module. I'm using a variable which is not defined, which is not declared in the start and the stop code. See if you spot which variable.
The A.
I've actually got A defined, or it's being assigned there.
Yeah.
I've got R being assigned there. But in this statement here, there's one more. H, right. So we're going to set the height of our cylinder as well. And I'm going to put it up here. If we were good boys and girls, we would put a declaration block that had that stuff in it. Then that way we could put them all in the same block. I'm going to go ahead and do that. Yay. Okay. Now I followed the book way. I didn't flowchart it that way, but if I was going to flowchart it, I would have a block called declarations, and I would put all my declarations in that single block. Yes, sir.
Can you say the set? Can you use VAR variable? Just curious.
Okay, please repeat question. I almost got it.
So, instead of using the word set,
Right.
or the command set,
I could leave the word set off, and I wouldn't count it.
can you use variable or the code the command VAR?
Yes, if that's what the book shows.
Oh,
I forget. I forget. Is that what the book shows?
Oh, no.
No. I'm not arguing with you. I'm
Oh.
trying to remember. Yeah,
No,
you could
we're-
call
we're
this.
not
I think
that.
let's go look. I think the book calls it num or var. Let's go look. I mean, if we're going to the trouble,
No, I was just curious.
I'm going to leave it like that though, just because
No,
we've been
that's
doing
fine,
that.
That's fine.
Yeah. I'm not arguing with you. I'm trying to remember how the book does it and wishing that I did it exactly the same way the book does it. Okay. Okay, they're actually preceding it with the name of the type of the variable. Like declarations. This is a string, and that's a number. So we could be preceding it with the word num. We could precede it with the word var. You know, pseudocode is kind of loosey-goosey. In Python, you don't give it a type at all, so I'm just going to leave it the word set. Very, very good question. Alrighty, so this is our code. I would like for y'all to flowchart this code. It's perfect, except I forgot to put a stop at it. Nope, I got my stop. I could put some comments here, but you wouldn't put the comments in your flowchart unless you just really felt like it. Calculate area of a circle. Calculate I swear I've got something wrong. Oh well. I think it's right. And for drawing the flow chart,
You
Doesn't
still
matter.
haven't defined pi, unless you import it.
just up at the very top of it, you could set pi equal to 3.1, or tell you what, yeah, let's do that. At the very top of our program, let's set pi like that. Better yet, why don't we find the import statement? But for pseudocode purposes, I don't mind just leaving that off. But when we actually write it in Python, we are going to need it to declare or import it. I got to find it. Import pi into Python. It's in the math module, which
That's not it.
that's not quite what we want. Import math and then use math.py. So if we wanted to do that at the top of our program, we could do import math and then pi equals math.py and then run from there. Or you could even use math.py right there in the calculations. It's just a little bit more typing, but you could do that. All right, but I'm going to scroll that off for now because we're not writing Python code. I want you to do this as a flowchart. I'm going to get rid of this just because you wouldn't know how to flowchart a global variable, and honestly, I don't either. Okay, there we go. Please to go ahead and flowchart that. And then I'll kick back in, in about 5-10 minutes.
You want us to flowchart the start and from between the start and the stop, or the
whole shebang.
Gotcha.
3 columns. And you know what? I'm going to print this out so that I can do something else. How many copies do I need to print? 1, 2, 3, 4, 5, 6, 7. Wow. We have complete attendance today. That's pretty cool. Okay, when I printed it, it kind of messed up the comments. It put the comment here, and then it put the rest of the comment here. If I had a pen, I'd cross those off as I passed it out. Just be aware that this stuff here, if it's got a comment there, the next line. Who's got a pencil? Yeah, I'm going to cross that line. That's not two things. I'm only doing this because I'm doing this very way. This is just one of the comments. I'll show you how it looks like. I forget I already said that's the comments, right? Plus some options. Code. All right. Thank you so much. Be sure to use your other one as a reference. This one doesn't have any input, so you get to skip the input stuff. When I took the input and I converted it to a float and stuff like that, this one doesn't have any of that stuff. If you're going to make it more fun as a program, you could add an input kind of here where we set R and H. We could ask for those values, but meh, not now. Alrighty, I haven't saved my flowchart recently, so I'm going to do a save as, call it June 20. Then I'm going to download it. You don't have to do this yet, but just doing that and saving it to my scripts directory. Alright, I want to draw our current assignment, and I'm actually going to put it on its own flowchart. Not that you had to, but I'm going to do a file new document just to unclutter things. Alright, so I'm going to grab my code and paste it into the flowchart just for ease of tracking stuff. Alright, all well and good. Alrighty. And I should have put my name and stuff like that on there, so I'm going to do that. And I'm going to describe what this does. Cylinder area calculation. I would like your homework to have a description of what it is. Whether you put the source code in it or not, it's fine. Kind of neat to have it there. Up to you. Alrighty. So how many modules did this guy have? Not counting the main code, the start-stop one.
Two.
Yeah, it had two. Alrighty. So I'm going to drag one of these guys over there. Define cal circle. The book doesn't add the word define, but we're cooler than they are. It has one parameter, radius. I see that from over there. I forgot the word set in my pseudocode over here. This is just plain math, so I'm not going to put it in a block with bars. How do I know it's plain math? It doesn't call any predefined processes, any modules that we wrote. Set area equal pi times radius to the power of 2. So this one was short. Since we weren't doing any input or whatever, even if it was an input, I wouldn't make you do the print and the float conversion. So anyways, a short function. Returns the area that was calculated. Alright, that's one of them. I'm going to do the next module to calculate the area of the cylinder. Which takes the radius, but it also takes two other variables, height and area. Well, they're having fun in that class. Alrighty. And what does it do? It has two set statements. Neither one of them is a module call. Although, honestly speaking, we could have made calculate cylinder call the cal circle module. The advantage of that would be we wouldn't have to call it separately down here in the start stop section, and also we could eliminate one of our parameters here. I'll demonstrate making that change, but not in the flowchart. Don't want to start and stop too much. So we have two set statements. They're not module calls, so we don't put them in the rectangle with bars. We don't put them in the predefined process call block. So set A1 equals pi times R times H. Don't put two statements in the same block unless they are just a declarations block, which this is not. These are calculations. And then set sil underscore area equal to 2 times, and I'm going to type in the rest of the formula, A1 plus area. And then I'm going to return that calculation as well. And I will print this out at the end for anybody who needs it. So if you're not caught up on typing it, that's okay. I'm hoping that you got far enough that you could kind of eyeball and go, yeah, I was real close. Or, oh, I see a couple of things I'm going to have to change. I'm not going to quite give us enough time for you to draw the whole thing, probably, unless you're fast at drawing these. Okay, I have 2 of these guys done. I'm going to do the main code, the start and the stop. Start's also going to terminator. We've got a declaration. Now, declarations are not a module call, so we're not going to use a predefined process. We're not going to use a rectangle with bars. We're just going to use an ordinary one. Declarations. Set R equals 100. Set H equals 10. The book calls them nums. Num R is equal to 100. Fun thing about pseudocode is we're allowed to be a little, we can improvise a little, as long as it's clear. All right, now this set statement. What kind of shape is that going to go in? How do you know whether it's a module call or not? Is that a module call?
It's a module call.
Yeah, it is a module call, so it's going to go in a predefined process. Which, if I could find, that would be awesome. There he is.
How do we know that?
Just by eyeballing it, and if it's got any calls here to something else that we wrote, call circle, we know it's calling one of our own modules.
I got Steven with the eyeballs.
Yeah, and if you make the shape wrong, it's easy to fix. You click the shape, you right click, you do change shape, and you pick your new shape. Now obviously that's wrong, so I'm going to right click on it, do change shape again, put it in a predefined process call block. The way I know that it's a predefined process call is because it ends in a parentheses. That's not the only way we know, because just the input function ends in a parentheses, but this is a module that we wrote, and since we wrote that, we have to put it in a block with bars. So set A equal to calc underscore circle, passing in the radius. And then we have one more set. Again, this is a predefined process call because it's a module call, a module that we wrote. We wrote calcil. Set AC is equal to calcil, passing in the area, the radius, and the height. And then outputting the area. Output goes not in a process block, not in a predefined. The other output that we did go in a predefined process block, but that's because we wrote a whole module for our output. In this case, we didn't write a whole module. We don't see any parentheses involved. We don't see us calling a module we wrote, so it's just going to go in an ordinary tilted rectangle. Output area of circle is, of cylinder. And since it's our main program, it began with a start, it ends with a stop. I forgot to draw a connector line here. Good enough. Go and add a stop at the bottom, and we're going to call this turkey done. All right, there's our whole shebang. Hopefully the YouTube video has high enough resolution. 1080p, I haven't checked. So that you can see all that. Alrighty, I briefly mentioned that we could make our code a little bit more, I'm not sure if the term is efficient, but what I consider a problem here is that we're passing in the radius here, and then we're passing in the radius here, and we're calling cal circle here, when we could just be calling cal circle from within this module and get rid of the need to call it separately down here. So if I was going to modify my code to look like that, I'm just going to copy and paste it. And mark it improved version. Maybe I'll describe at the bottom what's improved about it. Now the cal circle method is not going to change. But here we could skip passing in the area if we calculate the area. So set area equals, and then that function call, cal underscore circle passing in r. So down here, we don't need set a. We don't need to pass that in as a parameter. Now to me that's a little bit better. We got to eliminate a line of code down here. Our main code looks simpler. Even if this module grew by a line, I think it's better. To me, if I wanted to calculate the area of a cylinder, I wouldn't have to calculate the area of that circle first. That strikes me as annoying. That's like calling a function that calculates the area of a block, but as long as passing in height, width, and depth, you also had to print, you also had to pass in a separate area variable or something like that. All right. So why is that improved? We removed one of the parameters from calcil, did not pass in an area. We removed a call to cal circle in the main code. Let's start stop, making that code cleaner. And I consider this kind of a reduction of coupling, maybe a little bit, because before we had to call cal circle and then we had to call cal cylinder from our main code. And if we didn't call those in the right order or whatever, it wouldn't work. Here, we only have to call one function, so it's not order dependent. We're not having to call two functions in order to get all that working. Alrighty, and then briefly, I'm going to mention what the book would have preferred. Is that if we use the word num here, we use the word num here, we declare this variable here, right? Okay. Alrighty, onward and upward. So the mainline logic of almost every procedural computer program, and we are writing procedural programs, not object-oriented programs. Procedural means that you just call functions. Your program starts at a starts at the top. It calls some functions, it has some loops, has some if statements, and it gets to the bottom. Now we didn't throw any loops and we didn't throw any if statements. But so, they usually follow this program. Some declarations, some housekeeping tasks, steps you must perform at the beginning to get ready for the rest, like if we had to open a file or something like that. Some detail loops, do the core work of the program, and then some end of job tasks, stuff you do at the end of the program. So we might have to do some housekeeping like opening a file. Then we might have a detail loop that reads a line of data from the file and adds it to our total score, or does some calculation on it. And then the end of job tasks might be to close the file and then to print our totals. And we haven't quite been structuring our code like that because we haven't been doing stuff that was that complex. Not many detail loops, not any housekeeping, end of job tasks other than printing our result. So they give us an example here. Start, you do your declarations, you do your housekeeping, and then we have a loop here. Whenever I have a loop, I put the word while in my diamond. They don't. Works either way. I like to do that to distinguish it from an if, which is in the same shape. But you can tell if it's an if or not, or a while, because if it's a while, it loops and goes back up. If it's an if, it branches off, goes down, and rejoins down at the bottom. This doesn't rejoin anything, it loops back up. So, are we at the end of the file yet? No, we're not at the end of the file. Notice that they wrote this as reverse logic. If you covered up that word, and you just said EOF, the yes line would go straight down, because you're going to do the end of job once you hit the end of file. And the no branch would be out here doing the detail loop. But they flipped the logic of it by saying not EOF, which is something like saying EOF equals false, if or while EOF equals false. So just a little flipping of the Boolean values. I'm pretty sure I've talked about and or, not necessarily talked about nots so much. All right, and so they wrote a payroll program. Here's a much bigger version. I'm not going to talk a lot about this now, but it does show calling a module called housekeeping. So here they had a whole bunch of declarations, and then they called the housekeeping module. How do we know it was a predefined process? Because had a parentheses, I checked what was in front of the parentheses, that was a module we wrote. So I am going to put it in a predefined process block, a block with bars. That's what the housekeeping was, outputting a report header, outputting a column header, inputting a name, and then it returned. If the name was equal to quit, we do some details. That's another process call, another predetermined process call, which we see down here. And as long as they don't type in quit, we keep looping. Whenever they finally type in quit, we have one more module call called end of job. So we see two more process blocks, two more modules that better be provided for us. We have the detail loop. The detail loop asks for the gross pay, it calculates gross times rate, calculates a net, it outputs all that, and then it outputs the name, it inputs the name again. It inputs the name again so that they can ask whether the name was equal to quit or not. This is called a primary read up here, but that's another topic. And then the end of job. All of the end of job needs is to output the end of the thing at the report. It returns. So if we were going to stitch how this is called, we could draw a line. You don't do this actually. We could draw a line from housekeeping up here to that module call, and then from that return back there. And then from here for detail loop, we could draw a line, imaginary line, to the start of the detail loop, and then from the return back up there. And then here at end of job, we have an imaginary line going there and back there. But you certainly don't draw those, especially because one module could be called 100 times in your programs, and it'd be absurd to draw 100 lines looping around the page, going to the beginning of a module and returning back from it.
Jeff,
Yes, sir.
that actually goes to a question I actually had for you.
Yeah.
Instead of
Copying one line from Python and pasting it, say, 100 times, how would there be a faster way of doing
You write a loop. Yeah, the question is if you're going to be copying and pasting code, and we haven't even written any Python code, so why don't we do this? I'm going to launch idle. The question is don't repeat, or how do we stop from repeating line of code over and over and over? And the answer to that is we throw it in a loop. So I'm going to pop open idle, and I'm going to write some program that asks for test scores and adds them all up. And I guess I'm going to do it the way the textbook shows it, which is with a priming read. I'll point that out. Okay, so start. I'm going to print. Make the font slightly bigger for now. We can fit it. Later, we'll probably shrink it. All right. So, what is the test score? Or enter a test score. Something like that. And then we're going to print a message. Print. Or enter Q to quit. Now we have to have an input statement. Score is equal to input. Now we're going to get ready for our while statement. While score not equals Q. Because if they did type Q, we don't want to go into the detail loop and add scores and stuff like that. Now I forgot to do something, which is to declare a total variable. I need a total variable, also called an accumulator, in order to be adding up all these scores. So above these print statements, I'm going to go add a declaration block. So above those print statements, I'm just going to make the declaration block a comment. Total equals 0. Score equals 0. I'm going to go ahead and define all my variables, even though they're not strictly necessary in Python. I could skip declaring score because we just declare it there. But make our code look like the book. And in other languages, you do have to declare your variables before you can use that. All right, so this is what they call the housekeeping. I'm going to go ahead and add that comment, although I'll never add it again probably for the rest of the course. Alrighty, so that's our housekeeping block. Now we have our detail loop. While score not equal to Q, and we're writing Python, so every if statement and every while statement have to end in a colon. Let's add that score to our total, but we better convert it to a number first. You can't add a string to a total. You have to convert it to a number. So score is equal to float score.
What's that exclamation point for again?
That means not equal.
Gotcha.
You could also write it like this in this language. While not score equals equals. If you think that looks cooler, if that triggers in your brain better, that's totally great. But we have two ways of comparing things. Actually, we have more, right? We have less than and greater than and stuff like that. But we can either check to see if something is equal or with the exclamation point, not equal. All right, so we have the score, so why don't we add it to our total? You could do total is equal to total plus score. Or if you feel like shortening your typing, you could do total plus equals score. I'm not sure the book shows that, because the book is not a Python-specific text. I'm going to add a comment here. I don't necessarily recommend you type it, but total plus equals score. That's an alternative way of doing it. In pseudocode, you might just say add score to total, or you could do score set score equals score plus total. A couple of different ways. Now we need to ask them for the test score again. and we need to ask them to type in enter Q or quit. And then we need to ask them, we need the input statement. That's an annoying amount of stuff to have to repeat, but so I'm going to take those 3 housekeeping statements and also paste them into the loop, but we got to tab them over. Because we want them to be repeated every time, right? Not just enter 1 test score up at the top of the program. We want to ask a whole bunch of test scores. So it's got to go in the loop. And if it bugs you that we had some copying and pasting of code, which it does me, there is another way to fix that, but it involves what's known as a break statement. Or at least, yeah, there's a way to fix that. We could use an if statement to fix it. I'm just doing it the way the book shows right now. Now the book always puts end while as part of their pseudocode, so I'm going to add a comment that says end while. Not strictly necessary. Now what did they call the thing after the housekeeping and the detail loop? I need to remind myself. End of job. Alrighty. And again, this is something that I'm not going to be adding, a comment that I'm not going to be adding to the rest of my code. But end of job. All the end of job needs to do is whatever we want at the end of the program. Print. The total is, end quote, comma total. And if we kept track of how many test scores they'd enter, we could also calculate the average. I forgot to do that, so I'm not going to go back and modify the code to do that. And then I'm going to just have an input statement. Print. Press enter to quit or to end, and then have an input statement down here at the very bottom without even returning a variable. What's that do? It just stops the program at the end waiting for the user to hit enter, and that way if we double clicked on the program, from the Windows interface rather than running it from within idle, it wouldn't close so fast that we couldn't see the output. I think I've demonstrated that to y'all before. I hope I have. If you run this from Python, it goes, from the command prompt or from, by double clicking on the py file after you've downloaded it, it closes the window before you get to see any of the last output. But if you put an input statement at the bottom, it keeps you hanging around until you actually hit enter. Not a bad idea, not necessary if you're writing code just for running within idle, but I like it. All right, let me save my script. June20.py. Have I been calling everything June 18? No, I hope not.
No, I've seen you call some June 20. But those are mainly text files.
And in my flowcharts, I called them all June 18. No, I got that one right. I think. Woo. I'll bring the code back in just a second.
Whoa. Hey, Jeff.
Yes, sir.
When you get a second, there's actually a syntax error.
All right. I am not surprised.
I always forget those.
Yeah, and you forget them because we don't put them in the pseudocode. If you feel like starting to put them in the the comment was is if you leave the colon out, it stops working.
Yeah.
Absolutely mandatory in Python. If you feel like putting it in pseudocode, that's fine. The rule is that any time you start tabbing, the line above it has to have a colon. All right, let me walk around and make sure that we're all doing good. Alrighty, what I'm going to do at this point is I'm going to keep all this code here And then conceptually, well, I'm going to type something and then I'm going to delete it. I just want you to have this tucked away into your brain that you can do this. You could check to see if a string contains only digits or not. Let me remind myself how to do that. Python is digit. Okay. So here's what I do, is right here, I could do this. If score.isDigit, meaning it's numeric, and then I have to end it in a colon. Then I do that score equals float score, total is equal to total. But then I'm going to throw in an else to tell them that they did not type in a number. Else, I may just leave this here, but I hate putting in stuff, you know, making the examples too complicated so that when you get home, your eye is crossed. But we gotta make it perfect. So print, that wasn't a number. Please check your input. You know, that's enough. That's enough of an error message. And then the pseudocodes always show doing an end if, so I'm just going to put that in my code as a comment. All right, that would do it. If you type in something it doesn't recognize, like a lowercase q or anything that's not a number, it won't blow up. My question is it going to accept a fractional value? I made a 98.4. And my theory is that it's not going to. I've just forgotten. All right, so I'm going to type in some numbers, but then I'm going to type in some bad inputs, like some letters. It says that wasn't a number. It's working the way I wanted. Lo and behold, now I'm going to type in a 98.5. See if it blows up. It says that wasn't a number. So we should warn them, inner whole numbers only. Because this is digit function, just checks purely for digits, not digits and decimal points. So was that a good solution? Not really. Does that mean that I'm going to delete this? I oughta. What I'm going to do is I'm going to copy all this, paste it, put it at the bottom, and then undo it. So we have two examples. The same code, but with some error handling added. Go up to the top and take out my error handling. There's a better way to handle errors. Just want it to get tucked into your brain that you can check input. You can make sure that input has got alpha characters or digits or things like that, that it doesn't have any periods in it. Okay. Now that I went rampant like that, anybody need typing time? Let me come see.
I'm just running through testing it.
All right, common problems, leaving off semicolons, colons, while loops need colons, if statements need colons.
No, you're good.
All righty, so the last change that we had a request for was checking to see if allowing lowercase as well. So what we're going to do is we're going to say while score is not equal to q, and then we're going to use an and then we're going to say while score is not equal to lowercase u. And just to make this easier to read, I'm going to throw some parentheses in, which are not necessary. I'm going to put parentheses around there, around the score not equals to q, and then I'm going to close my parentheses before the and word. And then I'm going to come back over here and make it while score is not equal to lowercase q. And then my colon at the very end needs to be outside of all the parentheses. Have I talked about ands yet?
That you actually have not.
Well, then that's a brand new topic. Alrighty. You could accept it on faith at this point.
Yeah.
Okay. So now I ought to be able to type in a lowercase q and have it work. Or not. Oh, because I moved the error handling down to the bottom of my code, and the rest of y'all moved the non-error handling code down to the bottom. Alright, so this is just my text description of it. This is the same code, but with error handling. It checks to see if the input is a number with a call to isDigit, parentheses in parentheses, and if it is, it adds the value to the total, else it prints an error message. Alright, we'd better do pseudocode of this as well, but just a simple version. So I'm going to go back to my notes. You probably wish that I'd given you time to type that comment in. You typing it in, or are we all good? We're all good? Okay, good deal. Alrighty. So here's what the pseudocode for our last program looks like. There's no functions in it, so it's just a start. Then we add some declarations. Did we throw the declarations in a housekeeping step? Let's go look. Nope. So we had set total equal to 0, or num total is equal to 0, set score equal to 0. Then we had some housekeeping. Wait, I forgot my declarations comment. Declarations, there we go. Trying to make a book perfect. Housekeeping. Input score. Why don't we put our print message too, just so that they know what they're supposed to do. Output, input score, or Q to quit. So we input the score while score not equal to Q. We added the score to the total, and then we outputted that and we inputted that again. And I forgot a set statement. Set total equals total plus score. I output that. That's the int while. And then this was supposed to be the detail loop, so I forgot to put that comment there. Detail loop. And then lastly, why can't I ever remember? What's the last part called? After the detail loop, the end of job. Okay. Which was just to output the score. Okay, so that's a short version of what we did without error handling. Okay, I do want to talk about and or. If you have this, if hungry and we have money, go out and eat. We know what that means. You have to have both of those before you can go out and eat. Or you have to have a friend you can sponge off or a credit card. So, but what if we want to use an or? If sick, or tired, stay home. You see the difference in those? And means both of those have to be true.
Or it just means that
One has to be true, one or the other. And if they're both true, great. But at least one expression has to be true for the or to work. Both expressions has to be true for and to work. Now, what if we were writing some game that measured your hungry levels and your money levels? Then you'd have, something like this. If your hungry is greater than 0 and your money is greater than 0. This is just some kind of expression. And here, if sickness is greater than 0, or sickness is equal to true, something like that, or tired is equal to true, in either case, then stay home. Just showing you examples. This is more what your code's going to look like. You're going to be having comparisons like that, or comparisons like that. So that's the difference between and or. And both expressions must be true for the result to be true, or at least one expression must be true for the result to be true. And if you're an electrical engineer, there's the idea of an exclusive or, which means one and only one. If this one was true and this one was false, then it would trigger that, or vice versa. If that one was false and that one was true, it would trigger that. But if they were both true or both false, it would not. That's the exclusive or, and we don't do that in our if statements.
Do you want us to upload the...
Yeah, let's upload both the PDF and this. So it's about time to start winding down. I'm going to show you the homework assignment and make drop boxes for everything. And of course I'll paste it as a real document. But here's the homework. Flowchart this pseudocode. What's the pseudocode do? It calculates a paycheck based on the number of hours worked, including overtime. This code calculates a paycheck based on hours and wage, hourly wage, including overtime, at the usual, which is time and a half over 40. Now, how many people actually earn that anymore? I don't know. If you're a salaried employee, you certainly don't get paid for overtime. But anyways.
I did before I came up here.
Yeah. Okay, so how do we do that? Here's what our main code looks like. How do we know it's a main code? It's at the start and the stop. So, call get hours, call get wage, calculate our weekly pay by calling calc weekly, calculate our bonus by calling calc bonus, set our total, and then output bonus. That's dumb. It should be, why don't we output all three of them? Weekly, bonus, total. We could put them in 3 separate outputs. All right. So, that's the main code. And then we have functions that do the same thing. Here's a function called calc bonus, which calculates the bonus if our hours are greater than 40. We have a bonus. And there's more than one way to calculate these things. Sometimes people argue with my express formula. The formula I give you does work, but it's not the only one. And a calc weekly. And then 2 more functions, get hours and get wage. Now that's almost too much. We could just input the hours and input the wage down inside of our main program. So I'm going to modify the assignment slightly to do that. And then we're going to be done with our lecture. And let me make drop boxes. Should not have made the change at the last minute. All right. Common glitch in programming ideas is sometimes people want to input the total as well. They know that they need to print out the total, but no, we're calculating the total. But you are already used to that idea, like calculating, kilograms. You're not going to ask them for the kilograms after you've asked them for the pounds. Dropbox time. This will be Dropbox 5. All right, so for the daily tutorial, it's Dropbox F. And for the homework, it's homework assignment 5. All right, gang, any questions? I got a question. Are we going to have the the midterm on Wednesday? I'd rather do the midterm on Monday. The Monday following. Y'all okay with that? Having the midterm on instead of having it the 27th, having it on July 2nd?
Oh, yeah, yeah.
Now, anybody who was planning on taking the entire week off and cutting class on the 2nd is not going to like that. But all right. Midterm on that, and if you really do have to miss the day, it'll be available at the library, at the Learning Resource Center, at the Testing Center, so you can take it.